Hi, I was following the Blender conference and saw this amazing OK Go demonstration of how to use face capture to connect with Blender in real time. However, I don't own an iPhone and it doesn't seems to be an easy way to just use the same tools for people like me, which doesn't happen to have an iPhone. So I ended up uh, making this pipeline to be able to use a similar technique using face tracking and without the need of any iPhone or Android, just a webcam and your computer. So let's go. So for the face tracking, instead of using the MetaHuman, LiveLink, or other softwares I tried that were not really working for me, I propose you to use Touchdesigner. It is a software that you can use for free with a free license. That free license doesn't, it just limits the output video resolution in case of you using the software for that. Touchdesigner, if you don't know, it's kind of like artistic, interactive media live node tool, similar to Geo nodes in Blender, and it has some cool uh, hand tracking, face tracking tools that you can use. So here I'm using MediaPipe face tracking that it comes from Google and it's also for free. So just to explain you what's going on here, here is the node of MediaPipe that handles the actual face recognition and tracking. And all these nodes, what they're doing is classifying the all the information. So there's this node that takes care of kind of like rotations of the head and also translations in space. And these lag nodes, what they're doing is just, like having this G3 um, input data, you can actually smooth it out a bit. You can play with this value to get a more smooth data in by losing a bit of synchronization, like adding a bit of delay. So this is the head rotation and translation data, and this is all the micro expressions in the face. Like you see here, we have Joe open, so I'm gonna open, and there's a lot of them. For this tutorial, we're not gonna use all of them. This also has a lag node, and here I just use a math node that just simply multiplies by 2 every value, so it's more clear when it gets. And here we just merge the micro expressions data and the translation rotation data, and this goes into a OSC node that streams this data to the local IP. You need to set your actual local IP, not localhost. You can get it by typing on your terminal IP config, and you will get it there. It is using port 9000, and that's it mostly. You can also play in Touchdesigner with the speed that you get your data. If it's too fast, if it's slow, you can change your FPS settings here. So let's say I'm gonna put 10, so it's gonna be less data in case of I don't know, computer limitations, or you can go faster than that. So for the Touchdesigner files, I'm gonna share it on the description. You just download the zip file, you extract it, and you just need to open the only file. You make sure that you keep the Toxis folder in the same folder as the Touchdesigner file. You make sure that you have webcam available. If you have multiple ones, you can click on the main node one and choose here which one you want. And there's other options actually which are really useful, which are detect hands, also poses. Like you can actually do a lot more than just a face. You can detect the whole body just using, remember that this is for a normal RGB webcam, like this not any advanced uh, readings like the tutorials with iPhones or etc. It is not perfect, but it kind of works. So now in Blender, to be able to listen to the data that gets received through OSC, we need to install some OSC add-on. There's multiple out there. There's one called OSC Notes, if I'm right. The problem with the ones I tried to use were that while they do work nicely, they do not allow a way to record the OSC data, like record it as keyframes, so you can actually maybe do multiple passes of tracking. Like maybe let's say you want to animate first with your eyes, with your mouth, with your neck, store that information, and then apply it to other objects. So I did actually end up making a add-on. It is open source. You can find it on Gambro. It's called OSC Recorder. So how it works? We open the tools panel, and when you have installed it, you will find a tab called OSC. So you can leave the IP as the way it is, no matter what kind of IP you have. And the port needs to match the same as the one we have in Touchdesigner right here. So if you leave this checked, it would auto add every OSC address whenever it gets data from it. So remember that it's a ton of data that's going on from Touchdesigner. So when I click start, it's gonna, of course, show a lot of addresses and their values. That's okay. So we can stop it for now. Here, the names that we have, they do match the same ones in Touchdesigner. So this. So for the basic head rotation ones, I brought this instruction here, but you can find this more of them that are actually translation in space. Like if you move forward or backwards, you can actually check. I don't know all of them what they do, And the same for these micro expressions ones. Those are kind of descriptive, like jaw open, it's like when you open your mouth. And those are meant to be working with blend shapes, which are native in Blender. I will see how to use them in other ways. So let's say I want to grab M20, which is head horizontal rotation, Z. So we have to find M20, and this value we can copy it as new driver and then go to the object we want to animate and just paste it as driver. So we hit start again, and now we are controlling the cube with my head rotation. Actually, I put it in location, I meant rotation. Yeah, so I'm tilting my neck. And what else? We can use M21 for vertical rotation. So M21, the same, copy as new driver. And that was X. So we paste it in X. And we check. Okay. So you get the idea. So what I was mentioning about how to, you might be wanting to record the animation, the way to do it with this plugin is you set your scene, you hit on record, and when you click on it, the play in the timeline will start at the same time. So let's say you record, so you do your animation. When you're happy with it, you hit stop, and then you can replay what you recorded. But you might ask, like, where are the keyframes for this? If you want to convert this to keyframes, you go to the item that it's using the drivers, and you go to Object, Animation, and Bake Action. You can check on Clean Curves, and this would create the same, but in keyframes. You can actually check them on Graph Editor, and of course you can now modify these values or whatever you need. If you get some messy curves, you can select all the keyframes, and with F3 you can search for smooth, Gaussian smooth, and here you can decide how much you see here moving horizontally with your mouse. You control how smooth you want your keyframes, and that's it. This is useful, like if you need to record an animation and then use it, let's say, to animate another object, the camera. So once you have those things baked, you can actually reuse the same values as drivers for other objects. So let's see an example of using this in maybe a real case scenario. So in this setup, I have just these house, these buildings, and I've used the face rotation data to connect it to a camera. So right now I'm using my head as if it was like an aerial view, and I I did add a script for the E location, which is basically -10, meaning like it's a bit apart from the location of the buildings, plus the frame, like the timeline frame, divided by 10 just to make it a bit slower, because otherwise it would be just super fast. So what happens here is that if I press play, it's gonna be like something like a plane that I control with my face. And of course you can record this animation and do the same, bake it after that. So for our OK Go inspired face tracking animation, I have here a very simple geometries that they are not made using geometry nodes as in the OK Go demo. This uses, as you can see, very simple geometry, and this mouse that it's made using a curve, a circle curve, which is really fun to play with for this case. For the actual mesh, it uses the bevel, the default bevel way that it's included in the curve. So how do we use our face tracking data to animate this mouth? So for this, we're gonna use shape keys. So we're gonna select the mouth. I'm not gonna do a in-depth shape keys tutorial. There's plenty of them on YouTube. So basically you have to make a base shape key with nothing. Like that means it's the default state of the object. And then you start by adding different expressions. So we're gonna create one that's called the open mouth, set the value to 1, and then in edit mode you modify the mesh to match what you want to make with that. So for this one, I'm just gonna make open mouth, which is kind of simple. Now you go back to object mode, and playing with this slider, you see how it affects that one in particular. So what now? Now, because we have so many expressions to catch, we have to decide which one we want to use. So for this one, I do like the jaw open one. Like it does kind of work well for this. So let's find it in the OSC plugin. Jaw open here. So we do the same. as we did with the cube. We copy as new driver, and then we just paste it in the shape key that we just created, so we can test it. Okay, so the thing here is that we have so many of them that are all mouth related or cheeks or whatever. I'm gonna just add two of them, which are kind of enough for a lot of expression. So I'm gonna use mouth pucker. This is, in case you don't know, it's like the kind of like a kiss gesture, like so. That would add some nuanced for this mouth. So we first create the new shape keys and we call it kiss. We set the value to 1, and then on edit mode we will just modify it the way we want, and we have to find here the same one, mouse pucker. Copy it as new driver and we paste it as in there, so we test it. We could of course uh, try to find more expressions and mix them, because the more you add, the more rich you get on this micro expression, even if it's a very simple geometry. So now we're gonna um, animate the orientation of the eyes. So for animations that doesn't use shape keys, and they are actually meant to be used with shape keys, in this case we're going to use information related to eye orientation, but we're going to apply it to rotation instead of having to play with meshes of these eyes. So there is a problem with that, which is for the eyes, the information we get is we have information for both eyes separately. So we have eye look down left and eye look up left. But the problem with those is that they are gonna be both positive values. So if you see on the rotation X, when it looks down, it's a positive value, and when it looks up, it's a negative value. So let's try to first get the look down. So I look down left. We copy it as new driver, and again we paste it as driver. So we test it. Now I'm looking down. It does work. But what if I look up? Of course, it doesn't recognize it. So how do we get both? We can click on edit driver, and if we check here, we get the data that where it's coming from. It's actually an object called OSC reader that's get created automatically. So what we want to do is we're gonna rename this bar as down, and we're gonna create a new bar which is gonna be called up, and we just copy the same object where the data comes from. So we're gonna copy the path, the actual value inside the USC, and instead of look down we're gonna write look up. Okay, so now we get the data from look down and look up, and it's processed as an average value, which would result in cancellation of each other, which makes sense. They're opposite values. We need to change it to scripted expression, and here we can do like simple math expressions. Like before, we just had the bar down, which is this one. So we just need to write minus up, and if I'm correct, this should work. Like I'm now looking up and now looking down. If we find that these values are too, let's say, aggressive, we can put them inside a parentheses and then divide it by 2, or the amount that you want for the use case you need. So now when I look up, it doesn't go all the way up, and if I look down, you can still see the eye. So the same goes for the horizontal rotation. For those, I'm not going to do it, but I can tell you that they're called I look in, meaning in will be inside towards the nose, and look out would be the opposite direction of the nose. So that will be it. And remember that having this, you could again record the animation. So I'm talking, wow, wow, and then selecting the mouth and the eye. You go to object, animation, bake action, plane curves, and that's it. You stop, of course, the OSC add-on, otherwise it would be mixing the live data with the baked data. And remember that you can go to graph editor, and if you don't like some smoothing, that when you record it you can Gaussian smooth and make it smoother. And that's it for today. Thank you.